So good morning. I will be demoing for how to do the benchmark for our CPU, basically for the whole computer system. So we will be using some freeware to test to benchmark our computer, which are CPU-Z, Geekbench, MiniTools, and Task Manager. So first off, we will be checking our computer specification through CPU-Z. So we will just run CPU-Z, and then so when we run CPU-Z, it will take a few seconds to check the computer specification, and it will show this, and then it will show the CPU. So for this here, you can see that it shows the processor that is running on the computer. So currently my computer have a Ryzen 7 7435HS CPU. So currently it's running around 3000 to 4000 megahertz for the core speed. And then there's information also for the cache, like the L1 data cache, which is 8 times 32 kilobytes, and then L1 instruction is 8 times 32 kilobytes, and L2 is 8 times 512 kilobytes, and L3 is 16 megabytes. So this CPU have 8 cores and 16 threads, which is pretty common. And then we will now look at the main board, which is basically motherboard. So my computer is made by Asus, so the manufacturer is Asus Tech, and is the model of this laptop is this number, which is FA507 MBR, and it's running on PCI Express 4.0 bus, which is around 16 giga transfer per second. So the chipset that is running on this is AMD Ryzen, since it's running on Ryzen 7 CPU right now. So it's using a Ryzen SoC chipset, and then the BIOS is American Megatrends, and then we have the graphic interface showing that it's running on PCI Express 4.0 with currently is using width of x8. But yeah, so that's for the main board, and then we can check the main memory. So the memory currently running on DDR5 with 16 GB, and there's 2 times 32 bit of the channel. And currently the core frequency is around 1000 megahertz. The DRAM frequency is around almost 2400 megahertz. And then we'll check the speed of the memory here. So the max bandwidth is actually around 5600 mega transfer, I think. But probably the DRAM is, since it's dual channel, is running each DRAM is running at 2800 megahertz, and we can also see some of the RAM information, right? The manufacturer is by Samsung, and then we can see the part number and serial number, and then module size is confirmed is 16 gigabytes, and then we can also see the timing for each DRAM, I guess, here, and at what voltage is it running on. So that's all for CPU-Z. Next we will go to Geekbench. So when we download Geekbench and launch it, we will show this. So we will show some of the system information and CPU information. So for system information, you can see the operating system is running on Windows 11. And then this is my model of my laptop, and then the motherboard model number, and then it shows that the memory is 16 GB DDR5. After that, we can see more detail about the CPU that is running on my laptop. So as the same as what CPU this is running on AMD Ryzen 7 7435HS, which have 8 cores and 16 threads. But here we can see that the base frequency that shows here is actually 3.10 GHz. So this is what is most vendor going to be marketing the processor on, which is 3.1 GHz, but the maximum you can actually reach until 4300. This is actually I think it's the memory maximum frequency. It actually can reach until 4370 megahertz. So now we'll be running a benchmark and to get the CPU benchmark result, and actually I did it already, so you will see it here. So I did one, this one is actually a few days ago. So the score I gotten is, for single core is around 1804, and then for multi-core is 7322. 823. So when you run this, you will actually take like a moment. You will just run, and then you will, when it is finished, you will open up its own website actually to show the result, which is so you will show this result. You will show all the how they get the score here from running a few basically a few tasks like file compression, navigation, HTML5 browsing, PDF rendering, and yeah. So from all these scores, they will make a average score for the to show the single core performance and the multi-core performance. So and then there's also some extra CPU information to validate the information about your computer. And here actually you can see the transfer rate is actually higher than what it shown just now. So my memory can actually have transfer rate up to 4,786 mega transfer per second. So that's all for Geekbench. We now move to MiniTools. So here is the MiniTools. So we will now run for sequential first. So you just press, you go to this benchmark, and then you just you choose sequential, and then let it start, and then press start to let it run. It will take a while. Just wait for the result to wait for it to test for the result. So it will test on few transfer size, which is 4 kilobytes, 8 kilobytes, and 16 kilobytes, and 32 kilobytes, and it will show the reading and writing speed for each mode. So right now we can see for 4 kilobytes, you can really see the reading speed is around 696.917 megabyte per second for 4 kilobyte transfer size, and then for writing is around 277.984 megabyte per second. And then for 8 kilobytes, you can see that it is around 1222.82 megabyte per second for reading, and then 509.014 for writing. And then for 16 kilobytes, you can see it's around 1535.21 megabyte per second, and then 952.922 for writing. And then for 32 kilobyte transfer size is around 1657.15 megabytes per second, and then 1442.28 megabytes per second for writing. So this is for my C drive, for sequential testing. So here it shows that the writing and reading is increasing as the transfer size increase for sequential. After that, you test for the random test mode. So the same thing, we just change it to random, and then just let it start again. So we will now just wait for it to do the test. So right now we can see a few results already. For 4 kilobyte transfer size, we can see that for the random test mode, the random reading is around 662.766 megabyte per second. For then 246.291 for the writing. And then for 8 kilobyte transfer size, we can see that the reading is around 1243.42, and the writing is 259.08. And then for 16 kilobyte, you can see the reading is 1462.75, and the writing is around 259.233. And then for 32 kilobyte, we can see the random reading is 541.73, and then the writing is around 253.868. So we can see the trend of the reading speed and writing speed here. You can see that the writing speed is even though different transfer size is around the same. So and maybe that's the limit of the random writing for my disk here. And then there's a the reading is increasing as it goes to 16 kilobyte, but during the 32 kilobytes transfer size, it reduced to a quite low amount here. Maybe it's due to the property of the the hardware of the drive here. Maybe it's not optimized for 32 kilobyte transfer size here. So maybe that's why reading result is lower than expected here. So that's all for this benchmarking for using MiniTool. And lastly, we will use Windows Task Manager to benchmark a bit here. So when we launch Task Manager, it will show this, which is the process tab. So from here we can see how much your computer system is utilizing your CPU, memory, disk, and network, and also GPU. But we will only focusing on CPU and memory here right now for our test here. Sorry. So we so here we can see that it's running. My CPU is running at 27% because I'm recording also at the same time. So and then memory is around 65%. So when we launch a few applications, so right now I'm going to be launching Microsoft Word. So when we launch Microsoft Word, we can see that Microsoft Word is going to be using some memory, and because of I'm using other apps right now, it doesn't really show much here. It doesn't release that much. So I will be doing some documenting. So the memory does spike a bit, but it's only a few percent. I think maybe like 1%. So this is considered as low load, I guess. So that's for the low load. Okay. So when we close it, it will free up the memory, but yeah, you can see that 1% went down already, right? So yeah, when we close it, you will free up the memory. So now we will do for medium load. So for medium load, we will just be opening a few tabs of YouTube. So now we have 5 tabs of YouTube open. And now check on Task Manager, and we can see that Google Chrome is using a lot of memory here, around 1,400 megabyte, and we can see the memory spike to above 70%. So this shows that when we run medium load, it will use up like some amount of memory, and CPU usage will also increase a bit here. So yeah, this for medium load. And then lastly, we'll be doing high load. So for high load, I'll be running a game. Okay. So here we can see the game is launching, and you can see that the memory usage is spike up to 90 and above because the game is using the memory to load the game. And so you can see the Elden Ring is using up a lot of memory here, almost 6 GB of memory here, and it's using up also a lot of CPU usage here to load the game. So yeah, this is considered a high load for a computer system. That's all for Task Manager and benchmarking demo for the 4 freeware that we're using for this project.